Hi, welcome to this presentation on systems of linear equations. Today we will look at multiple systems of equations, and don't worry, it's not only for geniuses. You will learn 4 easy steps so that you can solve your own systems of linear equations. All right, let's get started. In this course, we are going to look at systems of linear equations that have two equations and two unknown variables. So first, we'll start with an example. Let's write an equation with two unknown variables. First, we have 2x plus y equals 4. Now, we need to solve randomly. So clearly, we don't know what the value of x is or what the value of y is. So we're going to choose random numbers. We can start with 1 because that's pretty easy. So if we put 1 in as the value of x, we get 2 times 1, which is 2. And then what can y equal so that the total equation equals 4? Y would be 2. All right, let's do that again with 0. This is another easy number to choose. 2 times 0 is 0, plus what equals 4? Y equals 4. And then we'll do one more equation with x equaling -1. These three values, 1, 0, and -1, are the simplest in order to substitute for the variable x. So here we'll do 2 times -1, which will be -2. What would y equal? 6, so that we can get a total of 4. All right, so now we have three different sets of coordinates. Here they are. Obviously, there's infinite solutions because you could substitute any value in for x. We are just using these three, 1, 0, and -1 because they're the simplest. Let's do one more. All right, here's our new equation, 5x minus y equals 3. So same like before, we've got two unknown variables. So we're going to do the same thing. We'll create this table with an x and y column, and we're going to choose three random values. So let's start with 2. If we do 5 times 2, we get 10 minus what equals 3, y equals 7. 0 can be our second value. 5 times 0 is 0, minus y equals 3, y would be -3. And lastly, let's make x equal 1. 5 times 1 equals 5, minus what equals 3, 2. All right, so this is pretty simple. Now we've got two sets of coordinates and two different equations. This one also has infinite solutions. I chose 2, 0, and 1 as the x values, but you can choose whatever numbers you want. All right, the two equations are independent from one another. So we've got the first equation with the table of coordinates and the second equation with its own table of coordinates. These equations are not connected, they're independent. But we can link them with this symbol. When we put this symbol next to the two equations, we are saying they're connected, they're no longer independent. Instead, they're called a system of equations. So two equations like this with this symbol to the left is called a system of equations. As you can see, both tables have the same x and y coordinate of 1 and 2. So that means the solution to this system of equations is x equals 1 and y equals 2. So if you were able to select the correct x values, you would eventually learn that by substituting 1 for x in both equations gives you the same y value of 2, meaning that that's the solution. But you might not choose these numbers at random. So we're going to learn a different way to solve a system of equations. There are three algebraic methods for solving systems of equations: substitution, reduction, and equalization. Today, we'll look at substitution. So, at the bottom, you see the systems of equations written. those two equations with the symbol to the left. First step, all right, we need to separate one of the unknown variables in one of the equations, and the other equation doesn't change. So we're going to move the 2x over to the other side to get the y variable alone. We're not touching the second equation. So as you can see, the first equation has changed. Y equals 4 minus 2x. Now we know the value of y in the first equation. The value of y is 4 minus 2x. The second equation doesn't change, as you can see by these circles. All right, so now we'll move on to the second step. We're going to practice substitution. These equations are the same equations you saw on the last slide. We need to insert that result that we just got into the second equation in order to create a new equation with only one variable. So we found the value of y, right? Y equals 4 minus 2x. So we're going to put 4 minus 2x into that second equation where we see the unknown y variable. So now our new equation with only one variable is 5x minus 4 minus 2x equals 3. Don't forget to use the parentheses. This will affect whether the values are negative or positive. So as you can see, there are parentheses around the y value. All right, moving on to the third step, we need to solve the new equation. Here's the equation from the last slide. 5x minus 4 minus 2x equals 3. And as you can see, the parentheses are there to indicate that we need to distribute that negative sign. So by removing the parentheses, we distribute the negative sign and we get 5x minus 4 plus 2x equals 3. Now we'll move the terms with the unknown variable to one side and the numbers to the other side. This should be easy. We get 5x plus 2x equals 3 plus 4. Complete the operations. 7x equals 7, which then leads to x equals 7 divided by 7, or x equals 1. Okay, now we know that x equals 1, but what about the y? We need to find the variable of the unknown y value. So again, we see here the two equations from the beginning. 2x plus y equals 4 and 5x minus y equals 3. This is our system of equations. The fourth step will be to substitute the x value into one of the original equations and calculate the value of the other unknown variable, which is y. So we learned by doing substitution that x equals 1. So now we need to put the number 1 in where the x variable is. You can choose either equation. Let's use the first one. So here we see 2x. We're going to put 2 times 1, since we know the value of x. 2 times 1 plus y equals 4. Y equals 4 minus 2. Y equals 2. So now we have the y value as well, which means the solution to the system of equations is x equals 1 and y equals 2, which we did see in the beginning in the first few steps that we did. But again, it can be random because unless you choose the correct x value at random, you might not find the solution. Substitution can help if you're not finding the solution quickly. You'll remember these tables from the first couple of slides. We see that both tables have the same x and y coordinate of 1 and 2, but substitution is a method that can help when we don't have time to choose many values at random.